Hello, this is Dr. James Camp of Lee College in Baytown, Texas, and this is the newest in my series on learning C++, how to use C++ to do math, or at least how to use the math that is built into C++. So the first thing you encounter in C++ are the built-in operators. And the built-in operators in C++ are probably the most limited of any of the computer languages. There's no power function, there's no root functions. It's basically a four-function calculator. So to add, we've got the operator plus. To add something to itself, we've got the plus equals operator, so that here we would say z equals x plus y, right? But what if we wanted to have x equals x plus y? Well, that takes a whole unnecessary keystroke to type x twice, so it would be easier to just say x plus equals y. Okay, so C gives us that little shortcut operator. And these operators, I should mention, are consistent across all of the C family languages. C, C++, C#, Java, JavaScript, even Apple's Swift language uses the same C-style operators. And then we have another special shortcut for to add 1. Okay, we have the plus operator. So again, y type x equals x plus 1, that's a lot of unnecessary keystrokes compared to just typing x plus plus. Okay, so all of these are equivalent here. You could type x equals x plus y. That's perfectly good C. But so is x plus equals y, and that uses fewer keystrokes and a shorter line of code. And similarly, you can type x equals x plus 1. You could also type x plus equals 1. That saves you one keystroke there. But you could save even yet another keystroke by just typing x plus plus. And any C++ or other C family language programmer, those are all equal and they all equally convey what you're trying to say. So to subtract, we have the minus operator, minus equals, and to subtract 1, we have minus minus. So again, we could come here and say z equals z minus 1, or z minus equals 1, or z minus minus, and those are all perfectly equivalent statements in C++. Okay, so those are adding and subtracting. We can also multiply using the star operator, the asterisk, the times operator. You have a times equals operator as well. Note that there is no times times because multiplying something by 1 doesn't make sense. And then divide, we use the slash character, and slash equals is the divide and replace with what you've divided. So here, you know, A equals A times 2 would work just as easily as saying A times equals 2. If we said B equals B divided by 4, that would be the same as saying B slash equals 4. Okay, so those all work. Now note, multiplication and division take what programmers call precedence over addition and subtraction. Okay, that means that in a line in which we write x equals let's say A equals B minus 2 times 3 divided by C plus 4 minus D, all of it times B again. Okay, how is this going to be evaluated? Well, C++ is going to come through, the C compiler is going to come through and look at 2 times 3 as being the highest precedence calculation there because it's the first multiplier divide on that line. Then it's going to look for the next multiply divide, which is this one. Then it's going to look for the next multiply divide, which is this one. So we're going to interpret this whole line as if we had put in parentheses here and there and there, and then we go through and we subtract from B and add 4 and subtract there. Okay, that's how precedence works. It's very similar to order of operations in regular math. Okay, but let's say we that's not what we had in mind. When we did this, we have to write in explicit parentheses to tell the computer exactly what we wanted. We wanted to subtract 2 first and then multiply 3. We wanted to divide the whole thing by C plus 4. We wanted to subtract D, and then we wanted to multiply the whole thing by B. Okay, so adding in parentheses is very important. Microsoft's Visual C++ will even occasionally tell you to add parentheses for clarity when they're not necessary, just to check that it's doing things in exactly the order that you wanted them to be in. And of course, this is C, so don't forget to put your semicolon at the end of the line. All right, now this wouldn't be a good lecture on math in C if I didn't explain the 2 kinds of division that go on in computers. So let me start by asking you, what is 7 divided by 4? Chances are when you first learned to do division back in grade school, okay, back in elementary school, you would have divided 4 into 7. You would have come up with 1 remainder 3. Okay, because 4 divides evenly into 7 one time, and you have a remainder of 3. Later, you learned that you could put the 4 under the 3 and get that this is 1 3/4. Okay. Later still, probably, you learned that you could convert this 3/4 into a decimal and that this answer could be 1.75. So today, you probably would put 7 divided by 4 into a hand calculator, and 1.75 is the answer you would get out. So if I asked you what is 7 divided by 4, you'd probably say 1.75. But each of these answers is correct. None of these answers is wrong. And it's important to keep that in mind when you ask the next question: what is 7/4 in C, or C++, or C# or Java, or any of these languages? The answer may surprise you. The answer is 1. Not 1 remainder 3, not 1.75, just 1. The reason for that is 7 and 4 are both integers. So we do integer division. And when your computer's integer calculation unit divides 7 by 4, it takes the number of times 4 goes into 7 evenly, which is 1, and discards everything else. What happened to the remainder 3? Did it just disappear? No. You just get that differently. There's a remainder operator. See, we use the percent sign because it looks like a division sign. So 7% 4, or you pronounce this 7 mod 4. Okay, 7 mod 4 gives us the answer 3. Okay, so if we wanted to tell the user what, to enter numbers, okay, we could see out number 1 divided by number 2 equals then we put out our first answer, the num1 slash num2 and then we'd say remainder num1 percent, or mod num2. Okay, and so that's a valid line of C++ code that if num1 was 7 and num2 was 4, it would print 7 divided by 4 equals 1 remainder 3. Okay, if num1 was 10 and num2 was 3, then it would print 10 divided by 3 equals 3R1, because in C, 10/3 is 3, 10% 3 is 1. Okay, so that leaves one last question. How do you get 1.75? Because that's really the useful answer here if we're doing any kind of engineering work or even financial work. If we had $7 and had to divide it into 4 payments, or if we had 7 centimeters and had to divide it into 4 lengths, or any kind of thing like that, 1.75 is really the answer we want. And the way you do this is you make sure one of the arguments to the division operator is a double type number. So I could write 7.0 divided by 4, and that would be perfectly equivalent to writing 7 divided by 4.0, which would be perfectly equivalent to writing 7.0 divided by 4.0. Any of those is going to give me the answer 1.75. Okay, so the key here is when you're writing code, remember that if the only inputs to a given equation are integers, C is going to do integer division. So never write the declaration double radius equals 2/3. Okay, because what C is going to do is look at this and say 2 integer divide 3, that's 0. Your radius is going to be 0. What you have to do instead, so never do that, what you have to do instead is write 2.0 over 3.0, and then you're guaranteeing that the computer will do floating point math and get you the answer you actually wanted. Okay. Now you may be, by this point, asking, what about powers and roots? Shouldn't there be an operator for, shouldn't there be an operator for z equals x to the y that looks like z equals x caret y or something like that? No, it is not that simple. There is no power operator in the C family languages. They were designed, these languages were designed to mimic the way computers do math, and computers, at least at that time, did not have built-in exponent functions. So you have to call a function. So the first thing we have to do if we want to do powers and roots is we have to pound include CMath. I have to pound include the CMath library. And this gets you a whole host of functions. The ones we're going to talk about right now is if we want z equals x to the y, this translates in C to the phrase z equals pow POW x comma y. Okay. If we want z equals square root of x, this translates to z equals SQRT of x. Similar for z equals cube root of x, gives us z equals CBRT of x. Okay. There is not a generic root function, however, that gets you any root, so if you want z equals the y-th root of x, okay, you have to say z equals power x 1 over y. Now, what did I do wrong here? This is a classic error. If I'm providing y as an integer, 1 over y is going to be 0. Okay? So I have to make this 1.0 divided by y. And now it will guarantee that the computer will do floating point math and get me the fractional power that I really want. Okay. What else is in CMath? There are a whole bunch of other useful functions. Trig functions in CMath are pretty much exactly as you expect. Cos of x, and you can do y equals cos of x, right? You can do sin, tan, and you can do the reverse, arc cosine, arc sine, arc tangent to input a sine and get out the angle, input a cosine and get out the angle. Note that CMath library functions always use radians. Okay, so if you're one of those people who thinks in degrees, you need to remember that angle in radians equals angle in degrees times pi over 180. And C does not have a built-in pi, so you have to define that constant for yourself at the beginning of your program. Okay, there are also hyperbolic functions. Okay, y equals cos h of x, or sin h, tan h, arc cosine h, arc sine h, arc tangent h. Okay, hyperbolic functions don't actually work on angles, they work on the hyperbola. So there's no need to convert anything from degrees to radians here. Okay. We also have exponentials and logs. So for y equals e to the x becomes y equals exp of x. If you want to get just the constant e, you can put exp of 1.0. Natural log of x in C becomes y equals log of x. For historical reasons, they made log the natural log, and if you want log base 10 of x, that's y equals log 10 of x. Okay. And then there are various others. Engineers and people in certain other fields may find themselves using the error function or the gamma function a lot. There are functions called ceil for ceiling, floor, and round, which convert floating points into integers. Okay, ceiling always rounds up, floor always rounds down, and round, as the name suggests, rounds to the nearest whole number either way. Okay. There's Fmax and Fmin, which you give two arguments to. So if you have two numbers a and b and you want to keep the highest one, you can say y equals Fmax of a comma b, and it will keep whichever one is the maximum. Obviously Fmin would keep whichever one is the minimum. And then if you want y equals the absolute value of x, that's y equals abs of x, and that's also given by the CMath library. Okay. Okay, and as usual, my closing notes on best practices in CMath. The first is that you can certainly do mathematical operations however and whenever in mathematical code, in C code that you want, but best practices is to try to be sparing in using math in variable declarations. So double y equals 1 over 2.0 times power of x comma 3 divided by z minus 3.0 over 4.0. You can see that this is starting to get kind of ridiculous, and sometimes it's appropriate to use this variable declaration. I mean, to use this in a variable declaration. For example, if it's obvious that this is what's going on, area equals pi times power of radius 2. Okay. Area is pi r squared. Everybody knows that formula. And if you've already input a radius, then using it to define the area certainly isn't a bad thing. Another thing in CMath, you'll notice I'm putting spaces in here around my operators. Okay, makes your code much more readable. You know, that is much harder to read than x, x equals, give a little space, y, give a little space, plus z over 3 times w over 4 minus 2. And this also lets you visually inspect and say, okay, where are my high precedence operators? And say, okay, C is going to group there, and then it's going to group there, and then it's going to group there, and then this plus here and this minus here are going to happen last. And is that really what I wanted? Maybe it is, maybe it isn't. Maybe you find, as you examine this, that putting in a parenthesis here is important because you wanted to add y and z over 3 before you multiplied by w. Okay? So spacing things out is a best practice for readability, but it also helps you examine your own code and make sure that you get what you wanted out of it. Finally, once again, an admonition to avoid magic numbers. In my area formula up at the top, this power of 2 is a magic number. As it happens, pretty much everybody knows that the area formula for a circle is pi r squared, so you don't need to define a constant, power of radius or something. But if I type the formula TF equals TC times 9 over 5.0 plus 32.0, you might be a little more confused about what's going on here. So I can, this is a do not do, okay? Better takes a few more lines of code, but better is to say const double degrees F per degree C equals 9.0 over 5.0. And see there, that's an appropriate use of math in a declaration. Okay. Const double freezing Fahrenheit equals 32.0. Okay. And then I can do temperature in Fahrenheit equals temperature in Celsius times deg F per deg C plus freezing F, because I have to offset the Fahrenheit scale from the Celsius scale by the fact that freezing is not 0 in Fahrenheit. Okay. Now, if you're someone who does a lot of temperature conversions, you probably recognized the formula that I circled and said no to up there. But I think you'll agree that whether you know temperature conversions or not, this second form is a lot easier to read, and it fits that standard we talked about earlier of being self-documenting. Okay. And also, again, notice that I put spaces around my operators here to space this out and make the whole thing easier to read. Okay. All right, so that's how to do basic and some advanced math in C++. More advanced math than this, factorials, averages, anything like that, not built into the C language. You're just going to have to write those formulas yourself, and we'll get into writing your own functions in a later lecture. Okay, thank you and stay tuned.